Next example, product mix type. A manufacturer produces two types of models, M1 and M2. Each M1 model requires 4 hours of grinding and 2 hours of polishing, whereas each M2 model requires 2 hours of grinding and 5 hours of polishing. The manufacturer has 2 grinders and 3 polishers. Each grinder works for 40 hours a week and each polisher works for 60 hours a week. Profit on M1 model is 3 rupees and profit on M2 model is 4 rupees. Whatever is produced in a week is sold in the market. Formulate the problem as LPP to maximize the profit. It is given that a manufacturer produces two types of models, M1 and M2. And two operations are performed on each model. One of the operation is grinding, another operation is polishing. Each M1 model requires 4 hours of grinding and 2 hours of polishing. 4 hours is the grinding time and 2 hours is the polishing time required for each unit of model M1. Similarly, each model M2 requires 2 hours of grinding and 5 hours of polishing. The manufacturer has 2 grinders and 3 polishers. Each grinder works for 40 hours a week. How many grinders are there? 2 grinders. And each grinder works for 40 hours. So 2 grinders will work for 80 hours per week. One grinder works for 40 hours a week. So 2 grinders will work for 80 hours per week. That is, grinding time available is 80 hours. And how many polishers are there? 3 polishers. Each polisher works for 60 hours a week. So 3 polishers will work for 60 into 3, that is 180 hours. So polishing time available is 180 hours. It is given that profit on M1 model is rupees 3 and profit on M2 model is rupees 4. ₹3 is a profit on 1 unit of model M1 and ₹4 is a profit on 1 unit of model M2. And whatever is produced in a week is sold in the market, so we can calculate the profit. Formulate the problem as linear programming problem to maximize the profit. We now put all this data in a table. So a manufacturer produces two types of models, M1 and M2. This is the first column, product type. There are two models, model M1 and model M2. Second column is requirement of time per unit of model M1 and model M2. Each M1 model requires 4 hours of grinding and 2 hours of polishing. 4 hours of grinding and 2 hours of polishing. Whereas each M2 model requires 2 hours of grinding and 5 hours of polishing. The manufacturer has 2 grinders and 3 polishers. Each grinder works for 40 hours a week. So 2 grinders will work for 2 into 40, that is 80 hours in a week. So grinding time available per week is 80 hours. And each polisher works for 60 hours a week. And there are 3 polishers. So 3 polishers will work for 3 into 60, that is 180 hours in a week. So polishing time available is 180 hours. Profit on M1 model is rupees 3 and profit on M2 model is rupees 4. ₹3 is a profit on model M1 and ₹4 is a profit on model M2. So we have inserted all the data of the given LPP in this table. Now let us formulate this LPP. Suppose a manufacturer produces X1 units of model M1 and X2 units of model M2. Now the objective is maximize the profit. So what is the total profit if the manufacturer produce X1 units of M1 and X2 units of M2? Profit on 1 unit of M1 is rupees 3. Therefore, profit on x1 units will be 3 into x1. Similarly, profit on 1 unit of model M2 is rupees 4. Therefore, profit on x2 units will be 4 into x2. Suppose that a manufacturer produces x1 units of M1 and x2 units of M2. Therefore, total profit will be profit on x1 units of M1 plus profit on x2 units of M2. Now look at the table. Profit on 1 unit of model M1 is rupees 3. Therefore, profit on x1 unit will be 3 into x1. Profit on 1 unit of model M2 is 4 rupees. Therefore, profit on x2 unit will be 4 into x2. Let us denote this equation by Z. That is, Z denote total profit of the firm. And we have to maximize this profit. So this is the objective function. Suppose this is equation number 1. Now there will be two constraints. One of the constraint will be on the grinding time. Another constraint will be on the polishing time. Let us find total grinding time required if the firm produces x1 units of model M1 and x2 units of model M2. Now, total grinding time in hours required for manufacturing x1 units of model M1 and x2 units of model M2. Now look at the column grinding time in hours. Grinding time of 4 hours required for 1 unit of model M1. So X1 units will require 4 into X1 hours of grinding time. One unit of model M1 requires 4 hours of grinding time. So X1 units will require 4 into X1 hours of grinding time. Next, 1 unit of model M2 requires 2 hours of grinding time. So X2 units will require 2 into X2 hours of grinding time. One unit of M2 requires 2 hours of grinding time. So X2 units will require 2 into X2 hours. So total grinding time required will be 4 into X1 plus 2 into X2. Now how much grinding time is available? Only 80 hours are available for grinding. So this is a total grinding time required to manufacture X1 units of M1 and X2 units of M2. This should not be more than 80 hours because only 80 hours are available. This should not be greater than 80 hours. This total, that is total grinding time, should not be greater than 80. Since only 80 hours of grinding time is available. In a week. Therefore, total grinding time 4x1 plus 2x2 should not be greater than 80. That is, total grinding time should be less than or equal to 80 hours. This is the first constraint on grinding time. Similarly, let us find another constraint on polishing time. Next, total polishing time required for manufacturing X1 units of model M1 and X2 units of model M2 is this is the polishing time. Each model M1 require 2 hours of polishing. So x1 units of M1 will require 2 into x1 hours of polishing. One unit of M1 requires 2 hours of polishing. So x1 units of M1 will require 2 into x1 hours of polishing. Now 1 unit of model M2 requires 5 hours of polishing. So x2 units will require 5 into x2 hours of polishing. One unit of M2 requires 5 hours of polishing. So x2 units will require 5 into x2 hours of polishing. So total polishing time required to manufacture x1 units of M1 and x2 units of M2 will be 2 into x1 plus 5 into x2. Now there are 3 polishers. Each polisher works for 60 hours in a week. So total polishing time available will be 60 into 3, that is 180 hours. This total polishing time should not be greater than 180 hours, because only 180 hours are available for polishing. This total, that is total polishing time required for manufacturing x1 units of M1 and x2 units of M2 should not be greater than 180. Since only 180 hours of polishing time is available, therefore total polishing time 2x1 plus 5x2 should not be greater than 180. That is, total polishing time should be less than or equal to 180. Suppose this is equation number 3. It is the constraint on polishing time. Also, the non-negativity constraints are there. Both quantities x1 and x2 are non-negative quantities. X1 is the number of units of model M1 manufactured or produced in the firm. This number cannot be negative. Similarly, x2 is the number of units of model M2 produced in the firm. This number cannot be negative. Thus, we have to maximize the profit. Using the available time for polishing and grinding. Hence, the LPP is maximize Z. Z is the total profit. Z is 3x1 plus 4x2. Subject to following conditions or following constraints. First constraint is on grinding time. Total grinding time should not be greater than 80 hours because only 80 hours of grinding time is available. 4x1 plus 2x2 less than or equal to 80. Another constraint is on the polishing time. Total polishing time should not be greater than 180. This is the total polishing time. It should not be greater than 180. So the constraint is 2x1 plus 5x2 less than or equal to 180. This is the constraint on polishing time. And in every LPP, non-negativity constraints are always there. So this is the required LPP.